can see, I made the text a bit smaller for number 12 so that I had a little bit of room to work. I found this problem kind of interesting because in physical science, we just finished talking about the difference between loudness and intensity. It says they're related by the function. Obviously, we didn't talk about the logarithmic function because it was 8th grade physical science, but still, this is definitely a physics concept here. So what I want you to see here is that they give us all the information we need here. Do you see that decibels goes right here, okay? And then intensity, the I part, is in watts per square meter. So right here is where the watts per square meter stuff is going to go. And then here, I sub 0 is 10 to the negative 12th. So 10 to the negative 12th is going to go right there. And so it's actually not that complicated a problem because they've given us all the information that we need. So let's start out with A. It says the loudness of a conversational speech is about 60 decibels. Well, we've already talked about the fact decibels are going to go over here. So let's just start. Basically, what I'm going to do is rewrite this equation or this function, replacing the information that I've been given into the equation. So here's 60 equals, and then 10 log, right? Okay, and now my I value. Have I been given my intensity? No, I have not. It says find the intensity. So we don't know I, so we'll just put I here again. Do we know I sub 0? Well, yes, we do. It's 10 to the negative 12th. Okay, so now we have a logarithmic function, and we just need to solve for I. All right, so remember, a logarithm is an exponent. So this whole thing right here, all of this is being multiplied by 10. All right, so I'm going to take everything and I'm going to divide everything by 10 because I'm working to get this by itself. Okay, so I know that I have 6 is equal to, just rewriting, and you need to take time to do this writing with me. Don't just watch and then write down the answer because your brain will not retain it like it will if you do this with me. Okay, so now I'm still not quite ready. Do you remember that division of exponents, right? Or I should say, I guess I should say division represents subtraction of exponents. All right, so the way that I can rewrite this, and we practiced this in class the other day, but the way that I can rewrite this is to say 6 equals log I minus log of 10 to the negative 12th. Now, what's the understood base right here? It's 10, right? Now, I didn't actually initially didn't take time to write it, but I think it's a good idea for me to do that just to remind you of what you know about this, okay? So if these bases, you see how this is the same? So that means this overall value of this right here is equal to negative 12. And then we have this negative 12, which gives us a positive 12, right? So then we have log of I equals 6. We are getting close. We almost have this by itself. All we have to do is subtract 12, and we get negative 6 equals log of I. Now remember, this is 10 to the negative 6th power equals I, right? You can solve that easily. If you plug 10 to the negative 6th into your calculator, you can easily get the value for I. And I'm thinking if you do everything right, you should get for I, you should get 1 times 10 to the negative 6th, and then it is in watts per meter squared. Okay? So there you have it. Not so difficult, really. Okay? Let's go to B. All right? So it says the threshold of discomfort to the human ear is about 120 decibels, which matches exactly with what we talked about in physical science. You can actually have pain if the sound is too loud. Okay, so we have 120 goes here. We know we're just recopying the equation. 10 times the log. Again, it says find the intensity. So we're trying to find the intensity. So you see the second one is going to be very much like the first one, 10 to the negative 12. So I'm going to work through that one a little bit faster, dividing both sides by 10, which gives me 12 equals log. And then I'm going to just separate them right away because I can do subtraction. Well, maybe I should. No, you guys can handle this. Minus log of negative to the negative 12th, right? Okay, so whoops. I missing some information here, log 10 to the negative 12, right? Okay, so understand these bases are the same here. That's why I can change this to a positive 12. We've got log I equals 12. Oh, this is looking risky, isn't it? Do you see how this negative 12 is going to give us 0? So we have 0 equals log base 10 of I. Now don't get too eager here. Watch out for this because you know the rules of exponents, I think. 10 to the what power gives us this? So 10 to the 0 power gives us I. So what is this value? What is the I value? The I value is equal to 1 watt per meter squared. Interesting, huh? Okay, so when the loudness doubles from 60 to 120, look, it started out at 60, and then our new loudness was 120, so it doubled. Now it's asking, C is asking, by what factor is the intensity multiplied? So the intensity went from 1 times 10 to the negative 6 to 1, okay? So when it doubles, or really what it's asking for is when it goes from this, no, it's asking when it goes from this to this, what is it multiplied by? So let's just add, let's set it up like this. 1 times 10 to the negative 6 times what factor? Okay, we'll just call that, let's call it F for factor, right? Equals 1. So we're trying to figure out what this factor is. That means we take 1 times 10 to the negative, divide it by 1 times 10 to the negative 6, divide it by 1 times 10 to the negative 6. You can enter that in your calculator if you want, or you can recognize that it's a factor of, it's going to be 1 million, okay? So the factor is equal to 1 million, okay? So by what factor is the intensity multiplied? By 1 million, okay? And that's the kind of the nature of logarithmic functions, okay?